Chapter 2, Lesson 5 of Advanced Algebra, we're going to begin looking at a new set of functions, absolute value functions, and what we want to do is to be able to recognize the equation and then recognize what the graph looks like just by looking at the equation, and then understanding how the values in the equation change the graph and change the shape of the graph. So we looked at linear functions and we looked at the different forms of the linear function. Remember, we had y equals mx plus b. The m is the slope, the b is the y-intercept. We had y minus y1 equals m times the quantity x minus x1. The x1 and the y1 are the coordinates of a point on the line, and m is the slope. Again, so it's really important that we know what the form of the equation is, and then we know what those different letters in the form actually represent. And that's going to be something that we're going to do all year long. So it's very important that we know the equation, what the different letters represent, and then how to calculate the values for those letters and how it affects the graph as we move forward. So the absolute value function equation looks like this. Y equals the absolute value of mx plus b plus c. Now you notice this looks very much like our linear equation, and we have mx plus b plus c. Now m represents the slope, so that's going to be the slope of the different sides of our absolute value. Well, let me just show you what that is. So m is going to be the slope. It's going to be the slope of these rays. So right now, if we make b and c 0, that makes these 0, that means we end up with this equation right here, y equals the absolute value of x. Now this is what we call the parent function. And the parent function is the simplest form of the function. The equation is in its simplest form, where all the values are 0 or 1, and the graph is usually centered on the origin or in the center of the graph. That's called the parent function. As we change the value of b and c from 0 to other numbers, that's going to change the placement of the graph in the coordinate plane. And we'll look at those in the next third video, I believe. Okay, so m is the slope of the rays, so the slope of this ray is 1, so from here you go up 1 over 1, and from here you go up 1 over 1. Now this is a negative slope because it's coming down, and this is the positive slope. So how do we get the negative slope? And I'll answer that question later. I'm not going to answer it in this video, but I want you to think about it, because this is negative because of what happens when we're solving absolute value equations. So kind of think about that and write a summary. In your summary, write down what you think the answer is to that. Why or how does this negative, this side of the absolute value become negative when this is positive if this is the slope? Okay, so all absolute value functions are going to look like this. They're all going to be V-shaped. And as we change the numbers, as I said, in the values of these variables, that's going to change the shape and the placement of the graph. Now, there is a very important point on the graph called the vertex, and it's the point of what we call the max or the min. And this is going to be a very important concept as we go throughout the year, because as we start applying these different functions, and a lot of them do have maximum points and minimum points, or vertexes, when we start applying these to real-world situations, it's the max and the min point that usually we're very interested in, because we are often interested in what the maximum of something can be. What's the maximum profit? What's the maximum volume? What's the maximum perimeter? What's the maximum area? And so when we apply this to a problem that talks about those concepts, we want to understand or know what the max is. Well, that means on the graph we'll be looking for this vertex point. In other cases, we'll want to know what the minimum is. So we want to know what the minimum cost is, what the minimum number of students is, or whatever. So again, as we apply the function to that problem, we'll want to find the vertex, because that vertex is the graphical representation of the minimum. So the vertex becomes a very important point in what we want to look at in all of these graphs as we move forward. So we really want to know how to locate that point. So we want to know how to locate it not only graphically but also algebraically, because many times the graph won't be exactly on the point that we want, so we'll have to calculate it algebraically in order to determine that. So we can determine the coordinate of the vertex in any absolute value function by taking the opposite of b over m. That will give me the x value. And then the c will give me the c value or the y value. So if I wanted to know or calculate the coordinate of this vertex right here, the x, I could take the opposite of the b over m. So looking at the equation, I can take the opposite of the b value, which in this case is 0, over m, which is the slope or the number right next to the letter x, 0 over 1, which is 0. So the x coordinate is 0 of the vertex. The y coordinate of the vertex is the c. Well, the c is out here, plus 0. Well, there isn't one, but plus 0 would make it the same. So I have the coordinate of the vertex algebraically, 0, 0, and that's confirmed graphically. As I look at it here, I can see where the vertex is. Okay, so those are the characteristics of an absolute value function and an absolute value graph. So we want to just be aware of those and make sure that we know what the equation looks like and then how to calculate the vertex.